All right, today we're going to continue with topic 1, atoms in the periodic table, lesson 3, bonding and the periodic table, found on pages 28 to 36 in your textbook. All right, as usual, I'm going to start with the connected. So circle the part of the image that shows the reactivity of hydrogen, and that is here where the reaction is happening. So that flame, the explosion, the smoke. Now, use the periodic table to predict why krypton, another noble gas, is not used in airships. And if we look at that on the periodic table, we can tell that it has a high atomic mass, so the airship would not rise. How would the results of the spark have been different if the Hindenburg had been filled with helium? And helium does not burn, so there would have been no explosion. Bonding. Most things you see in the world around you are not made up of individual elements. They are made from compounds or substances that form when atoms from two or more elements bond together. A magnesium atom, figure 2. How many valence electrons does a magnesium atom have? And we can see on the outer ring it has 2. Valence electrons. The first energy level is the closest to the nucleus. It can hold a maximum of 2 electrons. The second energy level can hold up to 8 electrons. Electrons in higher energy levels have higher amounts of energy. The valence electrons of an atom are those electrons that have the highest energy. They are in the outermost energy level. The electrons in the outermost energy level are the valence electrons. Electron dot diagram. Another way to show the number of valence electrons in an element is by drawing an electron dot diagram. An electron dot diagram includes the symbol for the element surrounded by dots, as shown in figure 3, or the picture to the right. The top, bottom, left, and right parts of the diagram can each hold up to 2 dots. Each dot stands for 1 valence electron. So at the top we have a Bohr model diagram, and at the bottom we have a Lewis dot structure dot diagram. All right, so here we are going to look at our groups and write how many valence electrons there are. So group 1, alkali metals, there is 1 valence electron. Group 2, alkaline earth metals, has 2 valence electrons. Group 14, the carbon family, has 4 valence electrons. Group 18, the noble gases, has 8 valence electrons. Valence electrons in the table. So the elements are organized by increasing atomic number. Therefore, the number of valence electrons increases from left to right across each period. Each period begins with an element that has 1 valence electron and ends with an element that has 8 electrons, except for period 1, since helium has only 2 valence electrons. For periods 2 and 3, group 1 elements have 1, group 2 elements have 2, group 13 elements have 3, group 14 elements have 4, and so on to group 18, which has 8 valence electrons. So reading check. Choose an atom from period 2 or 3. Do not choose an atom used in figure 3. How many valence electrons does that atom have? Support your claim. So if we chose boron, it has 3 valence electrons, and I know this because it is in group 13. Bonding and periodic properties. Elements are classified as metals, nonmetals, or metalloids, depending on their physical and chemical properties. What makes an element a metal, a nonmetal, or a metalloid? So metals. The periodic table shows that most elements are metals. Their properties, both chemical and physical, are determined by their valence electrons. The ease and speed with which an element combines or reacts with other substances is called its reactivity. Reactivity is based on the interactions of valence electrons. Chemical properties of metals. Metals generally have 1 to 3 valence electrons. Metals do not react with other metals, but they do react with other elements. Metals with only 1 valence electron are especially reactive. Most metals are crystalline solids. This is a metal crystal, a metal crystal is composed of closely packed, positively charged metal atoms. Each metal atom is held in the crystal by a metallic bond, which is an attraction between a positive metal atom and the electron surrounding it. So our question is, metallic bonding. The positively charged metal atoms are embedded in a sea of valence electrons. Aluminum atoms have 3 valence electrons. How do you think the reactivity of aluminum compares to the reactivity of other elements or other metals? Because aluminum has 3 valence electrons, its reactivity is lower than metals that have 1 or 2 valence electrons. Physical properties of metals. The physical properties of metals include malleability, ductility, and conductivity. Malleable material is one that can be hammered or rolled into flat sheets or other shapes. Ductile material is one that can be pulled out or drawn into long wires. Thermal conductivity is the ability of an object to transfer heat, and electrical conductivity is the ability of an object to carry electric current. So physical properties, figure 5. Metals have certain physical properties. Identify the property or properties of metals exhibited by each of the objects shown here. So copper is sometimes used in electrical wiring, that is ductility and electrical conductivity. This item is made out of iron, so it is magnetism, it is magnetic. Gold can be hammered into thin sheets known as gold leaf. This is malleability and it shows luster. Chemical properties. Atoms of nonmetals react with both metals and other nonmetals. For example, the metal sodium and the nonmetal chlorine react to form table salt, sodium chloride. While many compounds that contain nonmetals are essential to life, some nonmetals, such as the halogens, are poisonous and highly reactive. These levels of reactivity, as with metals, are based on the number of valence electrons in the atoms of the element. So figure 6, DNA, which is made up of atoms of nonmetals, is essential to life. List at least 2 other substances essential to life that contain nonmetals. This is water and air. Those are both examples. Nonmetals. Nonmetals have a much wider variety of properties than metals. Nonmetals have several properties in common. So, you can look at the image there if you want to see some examples. Figure 7, metalloids. The metalloids are located along a stair-step line between the metals and the nonmetals on the periodic table. Referring to the periodic table as needed, draw the stair-step line on this table, then write the symbol for each metalloid in the correct location on this table. So you need to have your stair-step starting at the end of boron, and it ends over to group 17. So yours should look like this. Metalloids. The metalloids have some properties of metals and some properties of nonmetals. All metalloids are solids at room temperature. Metalloids are also brittle, hard, and somewhat reactive. A metalloid's most useful property is its ability to conduct electric current. A semiconductor is a substance that can conduct electric current under some conditions, but not under other conditions. Examples: semiconductors are used to make computer chips, transistors, and lasers. Also found in solar cells. So here in figure 8 we have Planet Solar. Planet Solar is the world's largest solar-powered boat. The solar panels on its deck contain silicon and other metalloids. A semiconductor is solid at room temperature, brittle, hard, and somewhat reactive. So first we have a reading check. From the meaning semiconductor, what does the prefix semi mean? And semi means partly or not completely. And now we're at our lesson check. So we need to use figure 4 of this lesson to help determine the number of valence electrons in atoms of each of these elements. So chlorine is 7, calcium is 2, cesium is 1, neon is 8, 10 is 4, and indium is 3. Next, we'll draw an electron dot diagram for each element in question 1. And chlorine needs to have 7 around it, calcium with 2, cesium with 1, neon with 8, 10 with 4, and indium with 3. Underline each statement that is true about the element. Sulfur. Use figure 4 to help you. It is a metal. Each of its atoms has 16 electrons. It has a dull appearance. It conducts electricity. Each of its atoms has 5 valence electrons, and its electron dot diagram has 6 dots. So each of its atoms has 16 electrons. It has a dull appearance, and its electron dot diagram has 6 dots. 4. Hydrogen is a nonmetal with many nonmetal properties. Why is it on the periodic table with the metals in group 1? A hydrogen atom has only one valence electron, so its chemical properties match those of the metals in group 1. And that finishes our lesson.